Good morning all, this is Dr. Nageswara, Assistant Professor of Physics, SR and Severe Government Degree College, Autonomous Vijayawada. We are all using different instruments to measure various electrical parameters or electronic parameters. One of such instrument is multimeter. The multimeter will be used to measure various electrical parameters or electronic parameters such as resistance, current, voltage, inductance, capacitance, frequency, etc. So, but what is the inner side of the circuits we have inside of the multimeter we don't know. Such circuits are bridges. Those bridges are designed by different scientists to measure various parameters like inductance, resistance, capacitance, frequency, etc. One of such bridges is called Maxwell bridge. So, Maxwell bridge will be used to measure the inductance inside the circuit. So, what is the principle behind this Maxwell bridge? How can we consider this Maxwell bridge? How can we calculate the inductance by using this Maxwell bridge? We will discuss today in this presentation. So, in this diagram you see here, so where L1 is the value of inductance to be calculated, that is unknown inductance. Where R1 is the known resistance, R2 is the known resistance, R3 is the known resistance, C4 is the variable capacitor, known capacitor, and R4 is the variable resistance, that is known resistance. Where D is the galvanometer which is connected in between B and D points, where this is the alternating current source. So, where we are using alternating circuits, alternating current source, so these bridges are called AC bridges. So, in this Maxwell bridge we can calculate the unknown inductance. This is designed by James C. Maxwell in 1873. So, after his name we are called it is as Maxwell bridge. So, how its construction we will discuss today. In this construction, where unknown inductance L1 and resistance R1 is connected in series in between points A and D, and resistance R2 in the arm AB, known resistance R3 is connected in between CD, and variable capacitors C4 and variable resistance R4 are connected parallel to each other in between C and B. So, of course, this is galvanometer D and in which power supply is connected here. So, these are the different different instruments are connected inside the bridge. So, how can we use this bridge to measure this inductance? The principle behind this Maxwell bridge is Wheatstone bridge. What is Wheatstone bridge? What is Wheatstone bridge principle? Wheatstone bridge is also same as this one, but these four arms having four resistances only or four impedances only. For example, AD arm may be contain impedance Z1, AB contains impedance Z2, CD contains impedance Z3, and CB contains impedance Z4. By varying these impedances at such condition, the galvanometer current is 0, that is called balancing condition. At that balancing condition, we can write that Z1 by Z2 is equal to Z3 by Z4, that is called Wheatstone bridge balancing equation. That is the principle behind the calculation of inductance in the Maxwell bridge. So, before using this Maxwell condition, the Maxwell bridge, we want to know the values of impedances in different arms. We know there is resistance R1 where inductance is L1. We know resistance is opposes the current. And what about inductance? Inductance also opposes the current. It is nothing but inductance will act as resistance. How much is that resistance? That resistance of this inductance is called inductive reactance, that is called L omega. Or inductance is L1, so that is called L1 omega. So, these are in series, so that the resultant impedance Z is equal to Z1 plus Z2 or Z is equal to R1 plus L omega, that is called R1 plus J omega L1. J is the imaginary number. So, Z1 is the impedance across the arm AD. And what about in the second arm? Where R2 resistance only is there, so that impedance Z2 is equal to R2. What about in the arm CD, impedance Z3 is equal to, there is only R3 is there. But when we observe in the CB or in the fourth arm, the resistance R4 is there, which opposes the current. What about capacitor? We know capacitor also, which opposes the current, is nothing but it also acts as a resistance. Now, what is the resistance of this capacitor? That is called capacitive reactance. The capacitive reactance is 1 by Jc omega. So, there is two are parallel to each other. So, resultant resistance across the arm BCE, if it is Z4, we will use 1 by Z is equal to 1 by Z1 plus 1 by Z2, or 1 by R is equal to 1 by R1 plus 1 by R2. That is resultant resistance R to be calculated. So, by using that, if Z4 is the resultant impedance in the arm BC, we may write that 1 by Z4 is equal to 1 by R4 plus 1 by JC4 omega. 1 by R4 plus 1 by JC4 omega. What is Z4? When we are taking here LCM, then R4 is the LCM, that is 1 plus JC4 R4 omega. Now, by using that, Z4 is equal to R4 by 1 plus JC4 R4 omega. So, there we have Z1 we have, Z2 we have, Z3 we have, and Z4 also we have. Now, we can apply these four impedances in the Wheatstone bridge principle. That is Z1 by Z2 is equal to Z3 by Z4 at balancing position, or Z1 Z4 is equal to Z3 Z4, whatever it is. When we substitute these values into this equation, that is Z1 value and Z4 value and Z3 2 value and Z3 value. So, by multiplying this equation, we simplifying this equation, R1 R4 minus R2 R3 plus J4 into L1 R4 minus R2 R3 C4 R4, that is equal to 0. So, where we observe that there is R1 R4 minus R2 R3 is the real term. This is J omega into L1 R4 minus R2 R3 C4 R4 is imaginary term, because there is imaginary word J. So, by comparing these equations, real term and imaginary parts, real part is only R1 R4 minus R2 R3 is equal to 0. So, and imaginary part is this one, omega into L1 R4 minus R2 R3 minus C4 R4 is equal to 0. So, from the real part, R1 is equal to R2 R3 by R4. By using this equation, we can determine the resistance also. Actually, the main purpose of this Maxwell bridge is to determine the inductance. Of course, if inductance be known value, R1 can be determined by using this Maxwell bridge. If you know the R1 value, we can determine the unknown inductance L1 by using this principle. By using this principle, L1 is equal to R2, R3, C4, R4 by, that is R4, R4 is cancelled. So, L1 is equal to R2, R3, C4. So, when we are comparing these equations with the previous bridge, that is Hayes bridge, there is no frequency words in this equation. It is nothing but by calculating this inductance and L1, it is independent of the frequency. So that the accuracy values can be determined easily by using this Maxwell bridge, that may be inductance. So, by using this bridge, we can calculate quality factor also. We know quality factor Q is equal to L1 omega 1 by R1. L1 value we substituted here. So, that is the value, that is the quality factor. Of course, by using that quality factor, by using capacitor also we can use, that is Q is equal to omega C4 R4. What are the advantages of this Maxwell bridge over the remaining bridges? The first BT is there is no frequency, independent of frequency, so that we can determine the inductance and capacitance without depending on the frequency. And Maxwell's inductance capacitance is very useful for the wide range of measurement of inductance of audio frequencies. So, this is the uses of these Maxwell bridge. Thank you very much.